Welcome everybody, I'm Hartmut and we are here at the Machine Learning Conference in Berlin. I'm here with Oliver Zeigermann from embarc. Hi Oli.
Hey.
You just had a talk about where you explained how neural networks work.
Yes.
And there you started with the low-level API of TensorFlow. So
right.
Could you explain how that works?
So TensorFlow 2, which is the second released version of TensorFlow, changed its low-level API to make it more accessible for people who want to really understand what's going on, and also for scientific people who before often preferred PyTorch because it had the more approachable API. And in that low-level API, you write the training loop yourself. That means you write a loop, it's just a normal loop, where you use the existing model to make a prediction, calculate the loss, and based on that loss, calculate how to change the parameters, and then eventually change the parameters using an optimizer. And this uses maybe the most important feature of TensorFlow, the auto derivation module or API that makes partial derivations for you. And if you don't know what partial derivations mean, you don't have to care too much. It just does it for you.
Mm.
Yes.
And you showed an example, but you showed the same thing with the high-level Keras API in TensorFlow. So what's the difference here?
Yes. So in the low-level API, you have full control because you make a bunch of calls into the Keras, into the TensorFlow API, and you have a loop that does it, and you could change it in any way you want. Or if you want to really know what's going on, the low-level API is what you want. But if you want something that's more declarative, where you don't have to deal with all the low-level details, you use the high-level Keras API. And this is pretty good because you can't make a lot of mistakes. So if you write a loop and you change the order in which things are executed, or make other tiny mistakes, it just might not train. You have no idea why. But with the high-level API, you just declare what you want. So you configure a neural network and more or less tell the Keras API, now run that training loop under the hood that you don't have to write. Mm-hmm. So this is better for people who want to get started very quickly. Or it's also nice for larger projects where you want to share the code with a lot of people that may not have the same level of knowledge. So it would be the default API to use. Mm-hmm. You just no longer use it if you feel that you reach its limits.
Mm-hmm. So all you showed there was written in Python.
Right.
Is it the only language you can use?
So Python still is the most popular language in machine learning. But if you for some reason don't want to use Python, there at least is also TensorFlow JS, where you can write the same thing with pretty much the same API in JavaScript. That might be because you like JavaScript, or it might be because you need to write it in JavaScript because it has to run in the browser. But still, even if you use the Python programming language, you can still translate it into the JavaScript model and still deploy it into the browser if you want to. Deploying means you make it, the trained model, you make it accessible to API calls and do nice predictions with it.
Mm. Then TensorFlow has other APIs, for example, for Java. Is that at the same level than Python?
I wish it was. I wish it was. It's not now, and I'm not sure if it ever will be. But so I can only make wild guesses. But so far, if you're serious about using it, you will probably use the Python API rather. Mm. Even though as Java people, we would still like to see a good Java API, but not yet. No, unfortunately not. Yeah.
Okay. Then, final question: How do you get this into production? You have your models, you have your data here. How to get it working in real projects?
Yes, very good question. So I already started explaining that you can bring it in production in the browser, and there's tools that convert the native Python-based model into something that's consumable by the JavaScript library, and it typically works well even in the browser because in the browser you have WebGL, which can also access the GPU of your system via browser API. So typically it works well in prediction. It might take quite some time if you really train in the browser, so you need to scale it down a little bit, but for prediction it works well. And if you want to bring it in production on your mobile phone, you can convert it to the TensorFlow Lite version of TensorFlow, which simplifies the model, or could simplify the model a little bit, and maybe make integers out of floats and then cut some connections and make the model small enough to have it performing on maybe your Android phone if you have one. You have one?
Yeah.
Okay, me as well. And obviously you can also bring it in production on servers, and there's services where you just handle over the model and they will scale for you, or you can self-host the TensorFlow in serving mode. So TensorFlow actually, especially TensorFlow TOES, is geared towards bringing things in production if you really are serious about things. And then also maybe a small outlook, TensorFlow 2.1 will be even better in training on multiple GPUs. It's possible now, but they will improve on that. You can also train on TPUs, tensor processing units. So it's still evolving. We're close to the 2.1 release of TensorFlow. And the upcoming changes will be about making things still a bit easier. Yeah,
sounds great. So let's try it out. Thank you very much for these insights, and thank you for watching.